Before we start our tutorial video today, if you love our videos, please click on like button and make sure to click on subscribe and bell icon to receive notifications of future helpful content of automation and process control. Now let's get started. Temperature is probably the most widely used measurement. Galileo is credited as being the inventor of the first thermometer in 1595. Over the years the technology has evolved, and highly accurate and reliable devices are now on the market. New principles of measurement are being introduced, and existing principles are continuously improved upon. This tutorial provides some of the basic knowledge required to select the proper temperature measuring device. However, it is essential that the instrument selector take into consideration the user's experiences. For process applications, a typical temperature assembly consists of a thermowell, a temperature element, sometimes extension connecting wires, and a temperature transmitter, local or remote. Temperature elements frequently include a spring-loaded mechanism to ensure that the element tip makes positive contact with the internal bottom of the well. Units of measurement. The most commonly used units of temperature measurement are the Fahrenheit scale and the Celsius scale. The Fahrenheit scale was invented by Daniel G. Fahrenheit and was published in 1724. It is extensively used in the United States, although some industries are gradually converting to Celsius. The Celsius scale was developed by Anders Celsius, a Swedish scientist, in 1742. Degrees Fahrenheit, degrees Celsius, and Kelvin, used mainly for scientific work, are recognized internationally as scales for the measurement of temperature. The Fahrenheit and Celsius scales have been developed from two fixed points, ice and steam, at atmospheric pressure. Categories. Physical properties that change with temperature are used to measure temperature. For example, the property of material expansion when heated is used in bimetallics and filled system measurement. The electromotive force, EMF, principle is used in thermocouples, and electrical resistance changes are used in resistance temperature detectors, RTDs. Thermowells. Thermowells are used to protect the element, since they are typically fragile, and so that the element can be changed without interrupting the process. If a well is not required, a clear label should be attached to the element to indicate that no well is present. This is done for safety reasons. On the downside, thermowells create a time delay. If, for example, a temperature measurement without a well has a 1 to 10 time delay, this measurement may degrade with a well to a 20 to 50 delay. Thermowells are used in most cases where temperature elements are installed. There are exceptions to this rule, such as in internals of some equipment, such as compressors, turbines, etc. Bearings where space is very limited. Surface temperature measurement. Airspace temperature measurements. In addition to fast response applications, if thermowells create too much of a delay. Next tutorial we will go into details of temperature sensors and measurements. Thank you so much for watching and have a nice day.